Hello, welcome student. And in the previous lectures, we are just discussed the subtypes of the semiconductor in the headline of extrinsic semiconductor, and we are discussed the one subtypes of the semiconductor, that is the N type of semiconductor. In the same lectures, we are discussed the next type of the semiconductor, that is the P type of semiconductor. And after the discussions of the P type of semiconductor, we just compare between the what is exactly difference between the N type of semiconductor and P type of semiconductor. Okay, please take the heading of the next type, that is the type 2, P type semiconductor. P type semiconductor, this is the subtype of that extrinsic semiconductor. When a silicon and germanium crystal doped with trivalent impurities, when silicon or germanium crystals doped with trivalent impurities, some trivalent impurities, impurity, that is such as boron, aluminum and indiums. These are trivalent atoms. The borons, aluminum and indiums are the trivalent atoms is doped with doping in the pure or intrinsic semiconductor, that is silicon and germanium. This silicon and germanium pure semiconductor will be doped with some trivalent impurities, that is such as boron, aluminum and indiums, and we get P type of semiconductor. Then we get P type of semiconductor. Then indiums, boron and aluminums are the valency electrons is valency of impurity is 3. 3 electrons is available in the outermost orbits of that impurity, which can be added in the pure or intrinsic semiconductor here. Then we are drawn one of the same diagram in the same pattern which can be drawn in previous lectures. Consider this is a boron. Okay, consider this is a borons and they have 3 electrons in their outermost orbit. Then valency of that atoms of that impurity will be 3. The pink colors electrons are the electrons of the borons. Then we are placed with some प्युअर और इंट्रिन्सिक सेमीकंडक्टर, दॅट इज सिलिकॉन. एखाद्या ही जी इलेक्ट्रॉन्स किंवा हे जी इम्प्युरिटी आहे ते जर एका प्युअर सेमीकंडक्टरमध्ये प्लेस केला ठेवला, वी आर ड्रॉन द सेम पॅटर्न डायग्राम, दॅट इज सिलिकॉन्स आणि या ठिकाणी एक सिलिकॉन असणार. ठीक आहे, दिस विल बी 4 सिलिकॉन ॲटम्स या ठिकाणी आहेत असं कन्सिडर करायचं. देन this is not exactly but exactly circle. अशा पद्धतीने डायग्राम काढतो मी. Then and the green colors are the electrons of that particular silicon or semiconductor atoms. Okay, I will be drawn the proper methods of these diagrams. Consider this is the borons, that is B, exactly circulars. This one is, I'll be write the different colors for the drawing of silicon. That will be silicon. This is also silicon, and this will be also 4 silicon atoms, which we draw as the same pattern which will drawn in the previous lectures. ओके, त्याच पॅटर्न मध्ये आपल्याला थोडंसं ड्रॉन करायचं आहे. The diagram will be not exactly like that, and the atoms which can be colored in the green, these atoms, these electrons are the electrons of borons, and the same I will use different colors same like the silicon atoms. जे काही पिंक कलरचे जे काही कलर electrons are, these are electrons is silicon, and the green colors electrons will be electrons of borons. Then what happen exactly? Every trivalent dopant atoms will be share their all 3 electrons with the neighbor silicon atoms. ठीक आहे, हे जी काही ग्रीन कलरचे जी काही इलेक्ट्रॉन्स दिसतात, द इलेक्ट्रॉन्स ऑफ द बोरॉन ॲटम्स, ते प्रत्येक इलेक्ट्रॉन्स त्या नेबरच्या सिलिकॉन ॲटम सोबत शेअर केलेला आहे. देन दे मेक्स द कोवॅलेंट 3 कोवॅलेंट bond here. Then I will be write one of the sentence, same sentence. Every trivalent dopant atom share their 3 electrons, all 3 electrons or 3 electrons with their neighbor silicon atoms, with their neighbor silicon atom, and they form a covalent bond here with their neighbor silicon atoms to form a covalent bond. But fourth bond, या ठिकाणी जी काही फोर्थ बॉन्ड आहे, फोर्थ बॉन्ड इज इनकम्प्लीट. देन फोर्थ बॉन्ड विल बी, या 3 कोवॅलेंट बॉन्ड तयार झाले, बट हे फोर्थ सिलिकॉन जे काय ॲटम आहे, दे विल बी इनकम्प्लीट टू फॉर्म ए बॉन्ड और कोवॅलेंट bond between the silicon and its neighbor atoms. Then the fourth covalent bond, but the fourth bond between the silicon atom, their dopant atom, the silicon atom and dopant atom is not completed. Then the fourth bond is not complete here. The fourth bond is not complete. Then fourth bond complete नहीं है, then the each donor trivalent, जर ह्याला हा फोर्थ बॉन्ड कंप्लीट करायचा असेल तर एक इलेक्ट्रॉनची गरज आहे, आणि तो इलेक्ट्रॉन तो काय करतो, ॲक्सेप्ट करून घेतो किंवा ॲक्वायर्ड करून घेतो किंवा एखाद्याकडून इलेक्ट्रॉन्स घेतो. देन ईच डोनर ट्रॅव्हलंट ॲटम, प्रत्येक डोनर ट्रॅव्हलंट ॲटम कॅन ॲक्सेप्ट 1 इलेक्ट्रॉन फॉर द फॉर्मेशन्स ऑफ कोव्हॅलंट बॉन्ड. आणि त्या इम्प्युरिटीला काय म्हटलं जातं, दे विल बी ॲक्सेप्ट द इलेक्ट्रॉन्स, अँड दीज इम्प्युरिटी इज कॉल्ड ॲज ॲक्सेप्टर इम्प्युरिटी. देन each donor atom accept 1 electron from 1 electrons. It is called each trivalent, okay, this will be trivalent, each donor trivalent impurity or trivalent atom, each donor trivalent atom which accept 1 electrons, which can be accept 1 can be accept one electrons is called acceptor impurity, each donor travalent atom can be accept one electrons. या ठिकाणी एक इलेक्ट्रॉन्सची गरज आहे आणि तो एक इलेक्ट्रॉन्स तो ॲक्सेप्ट करतो आणि त्याला म्हटलं जातं ॲक्सेप्टर इम्प्युरिटी. And this I will be drawn in a different color. Why drawn in a different color? I will be explained next. A shared electrons creates holes. And ही जी काही shared electrons झालेला आहे, it will be create a vacancy. Then a shared electrons create vacancy or unavailability of electrons or absence of electrons in its place. Then a shared electrons create a vacancy in its place. Then these vacancy or absence of electrons or unavailability of electrons is called as holes. Then these vacancy is called holes. These vacancy is called as holes. In the n type of semiconductor, one electron is extra by the impurities. एक impurity कडून एक इलेक्ट्रॉन्स एक्स्ट्रा होत होता इन द एन टाइप ऑफ सेमीकंडक्टर आणि तो इलेक्ट्रॉन्स जो का आहे तो निगेटिव्हली चार्ज असतो आणि तो अवेलेबल असलेला इलेक्ट्रॉन्स तो काय करत होता डोनेट करत होता आणि या ठिकाणी एक इलेक्ट्रॉन्स याला कमी पडलेला ऑलरेडी आणि दे विल बी ॲक्सेप्ट आणि तो ॲक्सेप्ट करतो त्यामुळे त्याला ॲक्सेप्टर म्हटलं जातं आणि इन द एन टाइप ऑफ सेमीकंडक्टर ते डोनेट करत होतो त्यामुळे त्याला डोनर म्हणत होतो. These all will be different. Then these vacancies creates holes आणि त्या ठिकाणी इलेक्ट्रॉन्स होत होता आणि तो इलेक्ट्रॉन्स डायरेक्टली कंडक्शन बँड मध्ये जाऊन कंडक्शन घडवण्याचा प्रयत्न करत होता. इन दिस लेक्चर these vacancy create and the electrons, shared electrons will be create some vacancies at its place. These vacancies called as holes. Holes is available for the conduction of each acceptor atoms. Then holes is available आणि त्या ठिकाणी इलेक्ट्रॉन्स अवेलेबल होता आणि यामध्ये काय आहे होल्स इज अवेलेबल फॉर द कंडक्शन्स अँड होल्स आर मेजर कॅरियर्स. या ठिकाणी काय होल्स, द होल्स आर मेजर कॅरियर. द नंबर ऑफ होल्स आर मोर दॅन द नंबर ऑफ इलेक्ट्रॉन्स. The holes are major carrier, electrons are minor carrier. या ठिकाणी इलेक्ट्रॉन्स अवेलेबल नाही आहे, इलेक्ट्रॉनची कमतरता इम्प्युरिटीला ते काय करतं इलेक्ट्रॉन्स घेतं. इन दिस type of semiconductor the holes are major carrier, the number of holes is more than the number of electrons. These vacancies creates in the valence band आणि ही जी वॅकन्सी आहे these vacancy will be created in the valence band. This will be valence band and one another is a conduction band here. Then this vacancy is created in a valence band and this is the acceptor electrons and this vacancy is created in the valence band. Then holes are also created in the same valence band. The holes are also created in the valence band. Let's revise what we are discussing in these lectures and also we compare it with the n type of semiconductor of this semiconductor. When the silicon and germanium crystal doped with the trivalent impurities such as the boron, aluminum and indium and we get the p type of semiconductor. In the n type of semiconductor when the silicon and germanium crystal is doped with the pentavalent impurities such as phosphorus and something phosphorus, arsenic and antimonies, then we get the n type of semiconductor in that lectures. The vacancy of the impurity is 3 in a p type of semiconductor, but the vacancy of the impurity is 5 in the n type of semiconductor. We are study the comparison between the n type and p type of semiconductor here. Then the every trivalent dopant atom shared the 3 electrons with their neighbor atoms. Fourth bond is not complete and form a covalent band, and fourth bond is not completed. In the n type of semiconductor, every pentavalent dopant atom share their 4 electrons with their neighbor silicon atoms, and 1 extra electron is available in that sides. And each donor trivalent atom can be accept 1 electrons. This is called as acceptor impurity. And each donor pentavalent atom can be donate 1 electrons. This is called as donor impurity in the p type of semiconductor. A shared electrons create a vacancy. In that times, available electrons taking the part of conductions, and this type of they will be positively negatively charged, and this is called as n type of semiconductor. And in here, this is the p type of semiconductor. In the previous lecture, when we had discussions of the n type of semiconductor, the number of electrons is more than the number of holes. And in here, the number of holes is more than the number of electrons in a p type of semiconductor. And one thing we will be forgot to discussions in the n type of semiconductor, the conductions, the electrons goes in the conduction bands, and they are present in the conduction band. आणि जी काही conduction band मध्ये जी काही density आहे, it is a आपण डेन्सिटी कशी कॅल्क्युलेट करायचे डिस्कशन केलं होतं in the n type of semiconductor, and this is the p type of semiconductor. And we are also discussed with the comparison between the n type and p type of semiconductor is completed here. And let's discuss some features of the p type of semiconductor, and again the compare some all features about the n types and p type of semiconductor, and we are finished the both types of the semiconductor in the extrinsic semiconductor here. Let's start to discussions of the some features. Let's start discussions of the features. First features. The first features is the acceptor atom acquire the electrons and it becomes a negative charge. Acceptor atom, the acceptor atom acquire electron and it becomes negative charged. It becomes negative charged. In the n type of semiconductor, the electrons will be donate and they become a positive charged. In the second types, the number of holes is more than large than as compared to the number of electrons in the p type of semiconductor. That is, number of holes is greater than the number of electrons in the p type of semiconductor. In that n type of semiconductor, the number of electrons is more than the number of holes. The third features will be same. When the external energy is applied, the electrons which can be carried negative charge, the holes which can be carried the positive charge, taking the part of conductions. This is the same for both. Then this is all about n type and p type of semiconductor. In the next lectures, we discuss some problems on the semiconductor, and this will be individually discuss the n type and p type of semiconductor. What happened, the both type of semiconductor will be combined to each other, and what will be created we are discuss in the next lecture, that is a p-n junction.